All right, pre-calc students. So, after 2 days of really focusing in on graphing hyperbolas, we are going to today, or in this video I should say, focus on writing the equations of a hyperbola. So before we even get to that, we should talk about, because it's similar to an ellipse. When you were trying to write an equation of an ellipse, there were several things you needed. You needed the center, you needed r sub x, you needed r sub y, so that you could plug it into the equation. Alright, well, hyperbolas are not much different. There is one extra thing that you need though, okay? So we're going to make a little list here. Hyperbola. Alright, well we definitely still need the center. You know what, and actually I'm going to skip ahead. I'm going to say, let's look at the equation so we can kind of figure this out together. We know that the formula would be either this, right, where we have x minus h squared over rx squared. We have another option though, guys. We can also write our equation like this. Alright, so we have two options for hyperbola. Remember, or I hope we remember that. What's the major difference? Well, here x is in front, here y is in front. So that actually gives me a hint about the second thing I need. I need to know what the transverse axis is. I need to know the transverse axis. Why do I need that? Well, because once I know the transverse, I know which one of these I'm going to use. After that, guys, it's kind of the same. We need r sub x, and we need r sub y. Alright? So I really like these problems, actually. I know they're a little challenging. I know that you have to think outside the box, but these are good problems. And if you have like your end goal, right? If you know what you need, well then we know how to work and get to it. So let's try it. All right. For all of these, for every single one, draw a picture. All right, draw a picture. It's going to help. Let's see what's going on here. We want to write the equation of a hyperbola. Center is at the origin. All right, that's nice. Center is at the origin. We also know the vertices are 0, 1, and 0, negative 1. All right, so I know that up and down 1 are my, vertices. So I could do something like this, I could do something like this, and then what's going on? Because my vertices went up and down, that means that the transverse, let's start my list. So I need the center, I need the transverse, I need r sub x, I need r sub y. Alright, because my vertices went up and down from the center, I know that my transverse axis is the y-axis. So that's helpful. I also can probably get the center, well it told us, is 0, 0, and we can even get r sub y, right? We know that this, because it's the vertices, are 1 above or 1 below the center, well then my y radius is 1. And I care about that because now I can kind of sketch. I wouldn't worry too much about the asymptotes right now. Asymptotes are important for graphing, but for right now, we just need to have the general shape. Because, well, we need to get r sub x. Now, we think about everything. To get r sub x, we either need to know some things about the conjugate axis. We could figure, if we knew what the slope of the asymptote was, we could work with that. So in this situation, we actually have to understand that the final clue that we're given right here, we have to know that this is x comma y. So this is actually a situation where we need to plug in absolutely everything that we can, and then we're going to be able to solve for r sub x from our general formula. Alright, so let's write everything that we can. We know the transverse axis was y, so I know I'm going y first. Center is 0, 0, so it's just going to be y squared over r sub y squared, or 1. I know I'm going to subtract x squared over r sub x squared, and I know this has to equal 1. All right? Well, we have some points, right? We know it's at 3 square root 2. So if I plug in square root 2 for y, square root 2 squared, this is just a 2 over 1 minus 9 over rx squared, and that's equal to 1. All right, so if we do some rearranging, it looks like I'm going to just subtract this and move this over. So I'm going to have that 1 is equal to 9 over rx squared, or rx squared is equal to 9, or r sub x equals 3. All right, that's important. Now that we have r sub x, I can put it in, and now I can write my final answer. All right, really, it's going to be right off of this. It's just now we can replace r sub x, excuse me. All right, so we still have y squared over 1. We have x squared. Now we're going to put 3 squared as 9. And now we are done with our first problem. Okay, so think about this. If I ever give you a point, that's a good hint that you're going to have to plug in to the general form to kind of figure out what's missing. All right, let's check out the next one. Same idea, same concepts. We're going to draw some pictures, and then we're going to get the center, the transverse, r sub x, r sub y. So here we go. We have the equation of a hyperbola's center is at -3, -4. That's good. Ooh, we're given information about the foci now. All right, so let's sketch this as best as we can. All right, center is at -3, -4. So here's our center. Excuse me. We know the foci are -3, -8, so I have to go down another 4. 1, 2, 3, 4. Ooh, I'm sorry, it's just one focus. So we have a focus at -3, -8. So let's be really careful to make sure we label that as a focus. That's important. We also know that we have a vertex at -3, -2, so that's actually 2 above. All right, well, this tells me some things. I'm going to go and I'm going to make my list. Center, transverse, r sub x, r sub y. I would say that we can actually, once again, plug in 3 things. I know the center. The center is -3, -4. I know the transverse axis. The transverse axis is where everything is, right? Our vertex is up from the center. Our focus is down from the center, so things lie on the y-axis. That's good. Last one that we can write in right now. We can write in r sub y. We can write in r sub y because we know where the center is, and we know where one of the vertices are. And it's 2 away. So our y radius must be 2. Now, in this situation, this is one where if I give you a focus, well, we're probably going to have to use that. We can say that r sub f is 4, because if our center, or actually our focus is 4 away from the center. So this is important. In the one above, I gave you a point. And you were able to plug in to solve for r sub x. In this situation, if I give you a focus, you're going to have to use that focal radius as a hint. Okay? So, how is this going to work? Well, we need to remember some formulas. All right? We need to remember that r sub f, and actually, you know what? Before I do that, I'm going to go ahead and I'm going to sketch my picture. So I should put, actually, let's call that black dot, and I know that we're going to do something like this, and like this. All right. Okay. All right. My bad. So we know that RF squared is going to be equal to the that's transverse squared plus R conjugate squared. Well, we already said that the transverse was y, correct? So we know that RF squared is actually going to be RY squared, and if RY is the transverse, then x is the conjugate. And now we can go ahead and we can plug in what we have, which is pretty nice. We know that this is going to be 4 squared. We know this is 2 squared plus r sub x squared. I'm going to kind of skip a little bit. 16 minus 4, so we have 12 is equal to r sub x squared, or r sub x is equal to square root 12. And just to kind of remember that we would simplify that to 2 root 3. Alright, so now we know that r sub x is 2 root 3. Now we have everything we need. We can go and we can plug in. So first things first, we have the transverse as y, which means our y piece has to go first. We need to do y. The y coordinate of the center is 4, negative 4, so y plus 4 squared, all over ry squared, so 4. Then we take away x plus 3 squared. Instead of squaring 2 root 3, like squaring the 2 and squaring the root 3, just remember that r sub x is still down here as square root 12. So square root 12 squared is just 12. And of course, then we are done. And we bubble that. So we have our answer. All right, a few more. Aren't these fun, guys, right? These are good problems. These are good problems. They're kind of like puzzles. At least I think so. Okay, so here we go on the next one. In this situation, we know a center, we know an eccentricity, and we have one of the vertices. Okay, so that's good. I'm going to go ahead, I'm going to sketch a little picture. Alright, the center is at 1, negative 2. So somewhere like right there is our center. We have a vertex at 5, negative 2. That's a big deal. So 1, 2, 3, 4, 5. So now I know that I have a vertice. Actually, I'm going to go black. Sorry, black. And that was how far? 4 units away to the right, which means we then need to go 4 units to the left for our other vertice. 1, 2, 3, 4. And what have we been talking about? We know that the vertices lie on the transverse axis. So that means that we know this guy is going to open up left and right. Alright, something like that. Not perfect, but it'll get the job done. Alright, so again, let's go ahead, let's make a list of everything we can. Center, we already have. They gave it to us. 1, negative 2. Transverse, we know. It's it's the axis that the vertices lie on. That's the x. R sub x we have. We know that the vertices are 4 units away from the center, so r sub x is 4. R sub y, got some work to do. Alright, got some work to do here. So in this situation, we have now taken care of everything that we can from the picture, and the picture had the center and the vertex, so now we have to hit up this eccentricity idea. Alright, the eccentricity, similar to ellipses but slightly different, we have to remember that E is equal to the focal radius over the transverse radius. Alright, focal radius must be equal to focal radius over transverse radius. So let's think about this for a second. Well, I have that the eccentricity is 3 halves, right? So I'm going to put 3 halves. I don't have the focal radius, so I'm looking for that. I actually have the transverse radius, right? We said that the transverse axis was x, and we have that radius. It's 4. So I'm going to plug in. I'm going to cross multiply, and I'm going to solve. All right. Quick. Hopefully we can do that. So we have 12 is equal to 2 r sub f, or r sub f is equal to 6. Now we're not quite done yet. I know it's kind of goofy, but remember, focal radius is not what we're looking for. We're looking for that y radius. So this is the one where now we have to even, again, similar to what we did on the last problem down here, we have to remember that r sub f squared is equal to r transverse squared plus r conjugate squared. and that's what we're going to work on, or work with now. So let's do that over here. R sub f squared, R transverse squared plus R conjugate squared. So let's plug in. We have 6 squared. We have 4 squared. We have R sub y squared. Oh, I just realized you could not see what I'm doing. I'm very sorry, guys. Okay, so real quick, I'll explain again. I used that formula that we have for R sub f. I plugged in what I know. I knew R sub f, I knew R sub trans. Alright, so let's see here. 36 is equal to 16 plus R sub y squared. 20 equals R sub y squared. R sub y equals square root 20. I would probably rewrite that as 2 square root 5. Okay, 2 square root 5. And now I'm ready to go. Alright, now I am ready to write my equation. My equation will be something like, well, transverse is x, so x comes first. So I'm going to have to go x minus 1 squared over 16. Why? 1 from here, 16 from 4 squared. Minus y plus 2 squared over 20. Why? Positive 2 from the negative 2, 20 from ry squared, or right down here. And lastly, equals to 1. And we are done with that problem. Alright, so this is another example of a different type where if I give you eccentricity, you can work to get focal radius, and then if you have focal radius, you can work to get that missing radius. Alright? Well, we're getting there, guys. Alright, I think this next one's actually one of the easier ones. So hopefully this one won't take too long. Alright, we have vertices at -1, -1, and 3, -1. Alright, so let's see here. -1, -1, and 3, -1. So there's a vertice, there's a vertice. Hopefully you guys can already tell if the vertices are going left to right, then I already can sketch this picture, right? I already know the transverse is going to be x. I know it's not on there already, but we can get the center. We know that the distance between these two vertices is 4, so halfway would be 2. So my center is right there at 1, -1. So 1, -1. Transverse, we just said, was x. R sub x we have. If we have the center and we have a vertice, we know that R sub x is 2. And here we go. R sub y, we're not there yet. We're looking for it. But this next part is actually pretty easy, I think. If you can remember, okay, and think about this. We have everything now from our picture, like our vertices that we drew in. So now we have to use this other clue that we have an asymptote, y equals 3/2 x. I don't care about the intercept. I don't care about anything. I care about the slope. Because if you remember correctly, slope is always equal to plus or minus r sub y over r sub x. Well, this is nice. Clearly, I'm going to use the positive version, right? If this is positive, then I'm going to use positive. But now I can just plug in, right? I know that the slope is 3/2. I don't know r sub y, I want it. But I do already have r sub x. It's 2. And so once again, I cross multiply. 6 equals 2 r sub y, and I get r sub y is equal to 3. Right? Pretty easy if you think about it, right? So use the slope of the asymptote to help you find that missing radius that you need, because now, guys, it's the same thing we've been doing. My transverse axis is x, so x comes first. Hopefully you guys see why I have that, right? 1, 2 squared is 4, okay? And then I have y plus 1 squared over 9, and that should be equal to 1. Alright, there we go. Oh, I'm getting even worse with my squiggles as it goes on. Alright, last one. I know it's getting long. I want to do this one. just because I want you guys to have seen all of these different examples that I can possibly put on a test. Okay, hyperbola. We're given foci. This is good. This is interesting. Let's take a look at what this looks like. All right, so I give you foci 3, 7, 7, 7. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. So there is a foci. I'll put that in blue. Foci. I also have one at 7, 7. So 1, 2, 3, 4, 5, 6, 7. So I have another foci here. All right. Now, that actually we can get the center from that. We know that the center has to be directly between the foci. So if we're at 3, 7, and 7, 7, well then my center is going to be at 5, 7. Bad 5, 5, 5, 7. Now we can use our other hint to kind of help us out with the rest of this. We know that we have a vertex at 6, 7. So if I have a vertex at 6, 7, which is 1 away from the center, well then I have to have another vertex 1 away in the other direction. So I can now sketch this picture. Alright, it's not great, but it'll get the job done. Alright, something like that. So let's go through, see what we have. Once again, our transverse is, we know our transverse is x. We know because that's where the foci, that's where the vertices, that's where the center is. All right, transverse is x. We also know r sub x. R sub x is the distance from center to vertice, 1. R sub y, don't have it. Do not have this yet, but what we can remember is if we have foci, if we have information about the focal radius, you can always get the missing radius, all right? So now, because we know r sub f is equal to 2, and hopefully you agree, right? It's 2 away. Well, I can use this equation down here at the bottom. I'm going to go, so rf squared is equal to r trans squared plus r conjugate squared. Well, let's plug in what we know. We know we have 2 squared. R sub f is 2, so 2 squared. Our transverse is x, so 1 squared. I know the conjugate's going to be y, so r sub y squared. Clean this up. 4 equals 1 plus r sub y squared, or 3 equals r sub y squared, or r sub y is equal to the square root of 3. And guys, now we're done. Well, almost. Alright, we go ahead and we write this. We know that transverse is x, so x first, y second, square root 3 squared is just 3, and we are done with all of our problems, okay? So I know this video is kind of long. I get it. But honestly, I think this was a good video. It shows lots of different examples of the type of information I can give you, where you'll still be able to write the equation of the hyperbola. In fact, I kind of wish I made a video of this for ellipses because I think it was beneficial. All right, now instead of going through each one of these learning targets, I would really appreciate it if you could kind of, I don't know, take a look at this. Take 2 more minutes. I know I've already wasted 24 minutes. Take okay, 1 more minute. Read through, and maybe put a little check mark by the ones you know or questions so that you remember to ask me in class if there's anything on this list that you think you still need help on. All right? There we have it. We will practice these in class as normal. Have a good one. Peace.